Okay, because if it's 28 years, the population would not have exceeded 18,000. Or rather, the rate of increase in population would not exceed 18,000. So it is only upon 29 that it will exceed. Okay. So therefore,
So you cannot just put t equals the value of t equals to 9, 39.
the rate of increase for the first axis 18,000 when t was because I was thinking about my grammar and my English. The rate of increase in population first axis 18,000, 29 years after the beginning of 2006. I think that makes sense. Down here also. Okay, any questions? Okay, if not, that's it for 17.2. That means homework. I thought you know. Got it. Okay, I missed one end there. 17.2 can be due by when? Next week is week 7. Next week only got Emacs common test. Oh, okay, and chemistry, only 2, right? Only. Anything else? Just asking. Boss, this one, Wednesday? Both on Wednesday? Yes. I don't want together. Together really your homework gets longer and longer. Each mark, each piece I mark is so long. I'm going bonkers away, cannot. Okay? I cannot tolerate the long piece of assignment anymore. Okay, few pieces of paper, it gives it high deterrence to mark it, you know. Okay,
No, then why not you give the exercise letter lah?
Cannot. Yeah, it's all for your own good.
Okay.
It's okay. Yes. Stop making a business out of my batch or thing. And I earn my pay to do marking. Right, so exercise 17.2 Wednesday, then this one Monday can this is go 1. Okay, so can or not? Or it's open for negotiation at this point. I don't want it to be together. Okay. Otherwise, it's on Wednesday, it's on Thursday. I'm open to it. But then the day is that Thursday got Emacs test.
Or we use different paper, then you feel.
Then after if I finish 17.3, okay, I can't possibly finish it today. If I finish on Monday, then
Oh God.
it will be another set of homework. It will start accumulating.
How about you estimate to got Monday and Wednesday?
God bless I
I put it Monday, Wednesday lah. Okay.
What?
They're great.
By the way, next 2 weeks, I will not give you the PRWC question. Okay? I will offload you on that.
I love it. Love the music.
Okay, let's move into 17.3, the very last one. Differentiating logarithms. So this is low. Huh?
Is this trivial?
17.3.
Yes.
Not really.
Oh no.
Logarithm.
This is not trivial.
Love it.
This can't say this is not trivial.
Oh no. If she says that the weight is very hard, I have 100 marks your
Stop it.
Okay. Our question now is how do we differentiate when y is equal to ln x? Okay. So let's just do a very small proof, although it is not very rigorous. Okay. So if I want to differentiate dy over dx, that is what I want to find, right? Okay. And I don't know how to do it now. What if, okay, we know how to change the base, rather change logarithm to exponential form, right? Okay, or to indices form. So that means that y equals ln x, e to the power y is equals to x. Correct? And then, or rather, let me write it as x equals to e to the power y. Okay? X equals to e to the power of y, I know how to differentiate e to the power of y, okay, at this point. So if I were to differentiate with respect to y, so I differentiate x with respect to y, that is dx over dy, that will mean that it is going to be ey. Then you flip it forward, okay? And we know that dy over dx, okay, it is technically, okay, you can see as a reciprocal of e to the power of y. So then, you will put this back, this is 1 over e to the power of y. And what is y? Y is actually ln x.
Oh my god.
And e to the power of ln x will tell you that
1 over x.
it will be 1 over x.
Oh my.
So therefore, the derivative of ln x will be 1 over x.
Fun game. Have to change that, change
E
that.
power ln x.
Magic, magic, magic.
I need something to simplify.
Puzzle, puzzle.
Okay, so this definitely isn't intuitive, right?
Can you break down?
Break down what? I break down. That one?
Just
How do you
break
break
down.
down? Huh? What do you mean break down what?
Explain.
Explain again.
No, explain again. The thingy.
What thingy? What do you want me to explain?
No, but in primary school I think
How is
this
this
correction
correct?
it broke on me 5
You cannot read man. Y equals ln x. X equals to e power y. Change it into next form. Then you differentiate this with respect to y. Okay, then after that, dy over dx is a reciprocal one. Instead of the question,
Never mind.
never mind. Sometimes I really don't understand what I'm talking about. Okay, I'm very lost. Alright, try 12. Okay. We want to differentiate each of the following with respect to x. So your product rule, quotient rule, whatever rule that you know, you will apply. Okay, so x plus 1 ln x, if this were to be equals to y, so dy over dx product rule. Okay, so keep left, differentiate right, keep right, differentiate left. And then simplify this.
It's right. So is this natural, like we see ln something that is 1 over that thing?
Yes. So differentiating ln will always give you 1 over something. Okay? But of course, we will look later on into how chain rule applies in this case. Okay? So in this case, you can leave it as x plus 1 over x plus ln x, or you want to simplify it into 1 plus 1 over x plus ln x. That is also fine.
X to the power of x is what?
It's a power.
That's fine. It's a variable, yeah.
Does it apply to other log?
Yes, it will apply for other logarithms, okay? Not just ln, okay? It will apply to base 10 also. But usually we will always be differentiating natural log or common log, okay? We don't usually differentiate other bases of log. Okay, so part B, if I want to differentiate this, okay, let this be y. Alright, then in this case we apply our quotient rule. So keep the bottom, differentiate the top, minus, okay, keep the top, differentiate the bottom. over x squared.
Bottom.
Okay, and then we get 1 minus ln x over x squared.
Not x.
Okay, now looking at try 13, we will see how chain rule actually applies. So like we said, okay, we always differentiate the function itself first, then after that we differentiate whatever that's inside the function. Okay, so when I want to differentiate this, ln 2x plus 4, that means that I will be getting 1 over 2x plus 4. Whenever I differentiate the inside, I will always be doing the product, okay? I will multiply the differentiation. So differentiation of 2x plus 4, that will be 2. So therefore it will be 2 over 2x plus 4. In this case, it can be further simplified 1 over x plus 4. Okay, please make sure you simplify your answer in this case. Okay. For part B, to differentiate this, what do you think it will be?
1 over x squared. Then we do y squared. E to the power of x.
1 over
E to the power of x.
e to the power x plus 1, is that all?
Then
Times
ex.
e to the power of x, right?
What did I say?
Can this be further simplified?
No.
Yes?
Yes,
No?
yes, put it into separate fraction. No, cannot.
Huh? Can or cannot?
Cannot.
Yes? No? Cannot, okay? You cannot cancel, this cannot be placed into separate fraction. Rationalize is for certs, okay? You can only leave your answer in this manner.
This kind of answer that you can print out yourself was like 5 after you do this all the time.
Okay? Now for part C,
So, without root
y equals to ln x plus 1 square. How do we go about doing this?
you bring down the 2 first.
Should we bring down the 2 first?
No, wait.
Or do we have to use product?
So you 2, you make it a 2 ln.
Huh?
You can make it a 2 ln.
Okay, if you bring this down, y equals to 2 ln x plus 1. Okay, then after that we can differentiate this. What do you get if I differentiate this?
2 over x plus 1. Oh yeah, right. 1 over x plus 1. 2 over x plus 1.
2 over 1 over x plus 1. That will be 2 over x plus 1. So this is one way that you can do it. Okay, an alternative. Is there an alternative? I could use my chain rule as well. The square is only for x plus 1. Okay, so I could actually differentiate the logarithm. You will get 1 over x plus 1 square. And then upon differentiating this x plus 1 square, you will get 2 times x plus 1. Okay. Then after that, you can cancel out. You will still get 2 over x plus 1. Okay. You understand?
How you get the
This one.
yeah?
This one is differentiating x plus 1 bracket square. The chain rule part. And then this is differentiating the logarithm. Yeah, the ln part. Right? Any questions? So I think it's important that you familiarize yourself with both ways of doing. Okay, just in case you never know, you will get a sudden you're stuck somewhere, alright? And you don't know how to proceed. Or if you have any doubts. both the answers should be the same. Okay, one last one for the day. Okay, 1 equals to ln brackets x squared times sine x over x plus 1. Okay, how should we go about doing this? How do we separate this?
1 over x plus x over x squared.
One at a time. Well, yes. Okay, ln x squared sine x minus ln x plus 1. Is this right?
Yes.
Okay. What else? Is there any further simplification that you recommend doing?
Product rule inside too.
Do we have to do product rule inside?
So I'm talking about chain rule.
This one can simplify further or not? No? Can't get how to simplify further? Plus ln what? Very good.
Then I can do ln x.
Okay, all your logarithm rules are.
Okay, I'm done.
Okay, your ln x squared times sine x can be opened up using your logarithm laws. Okay, ln x squared plus ln sine x. Okay. Then I think at this point it will be easier for you to do the differentiation, because if you were to keep it to this form, not only do you have to do quotient rule inside, you have to also do a product rule. That is too messy. Okay, you will surely be lost after just the first line. Okay, so from here, dy over dx. Okay, differentiating ln x squared, that will give you 1 over x squared times 2x. Differentiating ln sine x, that will give you 1 over sine x, and then differentiating sine x will give you cosine x. Then after that, differentiating ln x plus 1, that will give you 1 over x plus 1. And then differentiating x plus 1 will give you 1. Right? Then after that, from here you simplify. Okay? Cosine over sine x. Should we simplify that? What does it simplify to? Tangent, right? Okay? Up to this point will be sufficient in its simplification. Any questions? Okay, we'll end here for today. Next week we'll continue.